Electrical machines are everywhere. They are used in small peripherals of the computers and laptops up and are gone up to the aircrafts and aircraft industry and so on and so forth. Even rockets. So innovation keeps on happening. Disk motors are one of these innovations, and I will be talking about these disk motors and how they came to being and why they are used. Disk motors have been used since 3 decades, and their constructions is as follows. There are these disk magnets, which are permanent magnets or the disk rotor, and these either are themselves magnets or have some magnets on them. Then there are bearings and the stator windings around them. These magnets are made of neodymium iron boron, which have high flux density. These are permanent magnets. These magnets have an almost linear demagnetization curve, and this curve, as negative field intensity is increased, the flux density is decreased linearly. This is a very good quality to have in permanent magnets. The inside of the machine,
there are the permanent magnets and the field bindings on the disk and the stator. The cross-sectional view. Now this cross-sectional view shows the shaft, which is connected to the rotor, and this rotor is very near the field windings. These windings provide the electric field necessary for the torque to be induced in the rotor, which then moves, and then the motor is functional. Why use disk motors? They have extremely high air gap flux density and really good torque speed characteristic curves. As you can see, there is almost 4 Tesla of field density at max, and the high speed torque characteristic shows at low speeds that it has high torque at low speeds, and this is an ideal characteristic to have for certain applications involving greater loads to be tugged, such as in the airfields. And therefore we will move on to the landing gears, which incorporate disk motors. Now early on, the landing gears had friction braking, and the whole of the speed was reduced by the friction systems, and that caused extreme losses and heat and sound and noise pollutions. Then motorized braking came in, and this motorized braking reduces the speed such that the relative velocity of the wheels and the runway is almost the same, and therefore less friction, less wearing would happen of the tires. This would increase efficiency, and this would help us. This would also incorporate regenerative braking, such that the generators in the landing gear produce electricity, which then is used to brake further, and this would help always. Then came the electric taxi system. This was also used for landing gears, such that whenever the generators would store the energy, it would go into a battery, and then it would be stored until taxiing was required. As we all know, around the airfield, the aircraft taxi, and this consumes a lot of fuel and is also required. So with heavy load, what to do? Disk motors. These disk motors are able to tug these huge aircrafts around the airfield, and this reduces by a survey that showed 4% of fuel consumption. This in turn reduced the pollution and the noise pollution as well.
Let's move on to designing and optimization. The key things to keep in mind are the geometric parameters, which are mechanical angle, the width of the permanent magnets, air gap thickness, core thickness, etc. Material selection is also very important. Winding design is also very important. All these factors are governed by the optimal design objectives, which are the rated torque, rated speed, rated voltages at which the disk motor would operate. These disk motors can be AC or DC. I studied the AC motors, AC 3-phase disk motor, which utilized the material for permanent magnets, which are neodymium iron 45. This had a great coercive force and produced high torques, and was therefore very optimal. The geometric parameters were calculated using different variant formulas and were then used to optimize this machine, which increased the torque by almost 1 Newton meter, which is a huge optimization. So this was Syed Samiruddin presenting disk motors. Thank you. If you have any questions, I would love to answer them in the class or whenever you meet. Electrical machines are everywhere.